Welcome friends to the agriculture channel. So today we have the topic that is the drainage. So it is also an important chapter with respect to water management in case of agronomy. And now what do you mean by drainage? So it is the opposite term of irrigation. As you know that irrigation means artificial application of water. But in this case it is artificial, we can write artificial removal of the water. Which water? Removal of water. Which water? Which is excess. So artificial removal of the excess water from the root zone is called as the drainage. Because as you know that if there is enough amount of water in the root zone, then what is the problem? The problem is if in the root zone or rhizosphere zone is filled with water, then it will create anaerobic condition. And due to anaerobic condition or means absence of oxygen, the root respiration will be affected. Hence, if the root respiration is not happening, then automatically the plant will die. That is why the drainage system is more important, that is artificial removal of excess water. So now before this you have to know what is the reason of excess water, what are the cause. So cause of waterlogging may be either excess rainfall which create flood condition, excess rainfall or over irrigation or poor natural drainage in subsoil. Because as you know that due to mechanization, the subsoil, in the subsoil there is a hard pan creation will be there. Just if this is the soil surface, just below which is present the subsoil, and in this subsoil there is a creation of hard pan. If a hard pan is there, then now the water cannot move down to the gravity. Due to the gravity force, the water cannot move down. Hence, it is restored over the soil surface. So, if in the subsoil a hard pan will be created, then waterlogged condition will be there because of no natural drainage system will be there. Then coming to seepage water from the side water source. Suppose here I have my field and just beside the field there is a canal is there or any water resource is there. But from this water resource, due to seepage the water will come to the field and it will create waterlogging condition in the rhizosphere zone. Okay. So these are the causes of waterlogging. So now coming to drainage means, what is drainage means? Removal of the excess water. So I have two types of condition, either water present in waterlogging condition. Here you can see this is my soil surface and just above the soil surface water is present, which is called as waterlogging condition. But in this case you can see there is no waterlogging condition, but still the rhizosphere zone is completely filled with water. This is why, this is because of rise in groundwater table. Because rise in groundwater table, now the water is cover the rhizosphere zone and it is also creating the anaerobic condition. Now the question is how to remove the water. So suppose I have two types of method of drainage. One is surface drainage and another is subsurface drainage. So basically the surface drainage means, we can say whatever the waterlogged condition, whatever the excess water which is present above the soil surface, if we want to remove this water, we can say called surface drainage. But here you can see here, suppose in this case there is no waterlogging condition, still the rhizosphere zone is completely filled with the water. So what I will do, suppose in this case I want to decrease the water table. I want to decrease the water table beyond the rhizosphere zone. So here I want to decrease the groundwater table, so that now the water level will getting decreasing and it will present below the rhizosphere zone. And this subsurface drainage is also helps, it also helps in extraction, or we can say the removal of the salt if it is present in the rhizosphere zone. Like in, you can say in saline soil. In saline soil you know that the rhizosphere zone, in the rhizosphere zone salts are present. Hence during the subsurface drainage the water table is getting down, simultaneously whatever the soluble salts which is already present in the rhizosphere zone, they will also getting leached down to the soil. So coming to first system, that is the surface drainage. So basically, as you know, that surface drainage means basically in generally we have to remove the surface water which is present in the waterlogged condition. So here, if you have an area which is somewhat flat, where the slope is less than 2%, hence in this case I can approach there different methods. First one is, suppose one is random system. Random system means suppose your area is somewhat scattered depression is there. In my area, scattered depression, both was different places, at different places some depressions are there. Okay, some depressions are there, and the depressions are shallow in nature. Hence what I will do, I will connect all the depressions, and make a channel of water, and all the water will be collected into a lateral ditch, and through the outlet, this is my outlet, and through the, you can see here, this is the slope, and through the outlet all the water will be getting drained out. Okay, so random system will be followed when there is number of scattered depressions and which are normally shallow in nature, and in this case randomly we should connect all the depressions, and then the final water will be drained out through the lateral ditch and come to the outlet. Okay, next coming to bedding system. Bedding system means if your slope is less than 0.5%, that means the bed slope should not exceed 0.5%, and in this case how you will, the condition is the soil should be shallow, the soil should be slowly permeable soil. The two conditions for bedding system, I have two conditions. First condition is the slope of the bed should be less than 0.5%, and the soil should be slow permeable. So basically here the bed is not that much of flat, so this bed is somewhat elevated. That means if any rainfall is there, so now if this middle portion is somewhat elevated, so now excess water will drain out. This is my parallel field drains are there, which are called as dead furrow. This is my somewhat elevated bed. Which bed? We can say the elevated bed. From this elevated bed, from two sides the excess water will drain. The excess water will come to the parallel drains. You can see here. So in this case, somewhat elevated bed is, you can see here, this, suppose this is my elevated bed. So if water will come here, then some of the water will come this side and some of the water will come this side. So this is like this. So in this case we can write there will be parallel field drain. You can see here those drains are parallel in nature, which are called as field drain, and these are called as dead furrow, and this dead furrow is maintained year after year. Okay, you have to cultivate the land in between the two field drain or two dead furrow, which is called as the bed. And the dead furrow, it is shallow depth. You can say the depth is very less. The depth of the furrow is shallow depth. Okay, here this is the thing. Shallow furrows are there, which are called as dead furrow, which will come to out. This is my outlet. All the shallow furrow, dead furrow will connect to the outlet ditch. Okay, so and here you can see the whatever the dead furrows are there, they are parallel to the slope of the land, and where the ditch, this ditch is across the slope of the land, because in this outlet ditch maximum amount of water will flow, hence it is present in the across slope in order to reduce the soil erosion. But in this case less amount of water will come to this dead furrow, and it is shallow furrow, so there will be parallel field drains will be there. So next coming to, this is called as cross slope collection by the outlet in order to decrease the soil erosion loss. Then next coming to parallel system or parallel field drainage system. It is almost equivalent to feeding system. Parallel field drainage system almost equivalent to bedding system. But the thing is that in the bedding system it is somewhat elevated, but in parallel system my land is flat. My land is flat and it is graded properly. My land is flat and it is graded properly. But now the thing is that it is applicable both irrigated and rain-fed area. This is mostly practiced in widely followed method. Which one? Parallel system or parallel field drainage system. It is mostly applicable for irrigated and rain-fed areas. Okay. And now the question is, the difference was the land is properly graded, and in this case the drains are somewhat deep. As here in the dead furrow, in the bedding system, dead furrow is there, so shallow drains are there. But in this case, the depth of the drain is somewhat more, and here you can say the equal interval is there in between the two dead furrow in this bedding system. You can see this is the two, this dead furrow, one dead furrow, another dead furrow or drain, and there will be equal interval between the two drains in case of bedding system. But in this case there will be not equal interval between the two drains. Okay. Next, coming to parallel open field ditch system. Always remember, whenever there will be ditch, so ditch means a deep drain. Ditch means a deep drain. As you know that, suppose I have a land, here I can write, suppose I have a land and that drain is very much deep. If deep, then surface water will come, as well as the seepage loss will come from the subsurface region. Okay, suppose this is the drain depth, or the depth of the drain is very more, or deep drain is there. That means from the surface, which is more excess water is there, it will come to the drain, which is called as a surface drainage. As well as you know that seepage means lateral movement of the water. So here there will be seepage loss. This is in this land area, all water logging condition is there. Excess water will come to the drain, which is called a surface drainage, and just from due to the lateral movement of water, the water will come to the drain by means of seepage from the subsurface layer. So ditch means what? Always remember, ditch means the depth of the drain will be very, very high. As well as you can see here, open ditch system, I have written open ditch system. Open ditch means first one is deep drain will be there and the side slope will be there. Whatever the drains are there, they will be somewhat slopy because it will extract more and more amount of water, because water will come from the surface as well as water will come from the seepage loss. Okay, so basically seepage means what? If I will write here, seepage means lateral movement of water. So here, if this is the lateral movement of water. Lateral movement of water is called as the seepage, and this is all normally it is happens in the unsaturated condition. Okay, whereas percolation will occur in case of saturated condition, downward movement. In case of seepage, lateral movement of the water will be there. So now, parallel open ditch system, it is similar to parallel field drainage system, but the thing is that the drain depth is very, very high and side slope will be there, and it will drain both surface as well as the subsurface drainage. So drains are replaced by the open ditch. Here drains are there, but in this case open ditch will replace the drains. Then next, coming to fifth number, broad bed furrow. It is mostly practiced, it is mostly asked in the different examinations. This broad bed furrow is a type of drainage system. Which type of drainage system? Surface drainage system. In this case, it is applicable in case of clay soil and for groundnut crop. The slope of the land will be 0.5%. Okay, so whenever we are saying that broad bed means the bed width will be 120 to 150 centimeter, and over this bed you have to raise the crops, and the bed is raised bed. We can say it is the raised bed, and the bed is somewhat 15 centimeter high. So raised bed will be there, and the furrow, you can see here the furrow, there is side slope will be there. There is here, you will see side slope is there, like this side slope is there in this broad bed furrow. So that furrow, we can say it is raised bed, so the furrow depth is 15 centimeter. Obviously This is broad bed furrow. Then next coming to interception drainage. Here whatever we have studied, the slope is less than 2%, but in case of interception drainage, if your slope is more than 2%, it means you have some slopy surface. As you know that this is my slopy surface, so now water will move like this, but you know that due to decrease the erosion loss, so you have to make some drain across the slope. You have to make some drains which is called as cross slope ditch. Ditch means, I have told, ditch means deep drain. Ditch means deep drain. Okay, so across the slope, always remember, across the slope, what I will prepare? I will prepare cross slope ditch, and this across slope the water will be collected, and now water will enter into the laterals. Then again from the laterals it will come to the main, okay, main drainage channel. This is, so interception drainage, as you know that it is a ditch, so as it is a ditch type of, so cross slope ditch will be there, so it will create both surface drainage plus subsurface drainage, because the depth of the drain is very high. This is mostly practiced in slopy area, or we can say the hilly areas. We can go for the interception drainage. Okay, then this is the complete part of the surface drainage. Coming to subsurface drainage. So what is the purpose of subsurface drainage? So I have already told that our purpose is to, suppose I have go for, there is two types, one is pipe, another is tile. Suppose I have taken the pipe, there is PVC pipes, and which are perforated, the pipes are perforated. The pipes are, we can say the pipes are perforated. Then what will happen? If the pipes are installed below the rhizosphere zone, always remember, if the pipes are installed below the rhizosphere zone, then what will happen? Now the water which is present above it will enter the pipe, into the pipe, and it will be drained out. So automatically the water level in the rhizosphere zone is getting decreasing, obviously. So there will be no problem of the anaerobic condition or waterlogging condition in the rhizosphere zone. So this subsurface means I want to decrease the groundwater table below the rhizosphere zone. So my purpose is to create aerobic condition in the rhizosphere zone. So here first one is a natural system of drainage. So if your land is rolling topography or undulating topography, I have already told, if you have rolling topography or undulating topography, so you have more depressions are there. So in this case I want to drain isolate area, some areas I want to drain the waters. Okay, this is called as the natural system drainage. Then coming to grid iron system, these three are more important. One is grid iron, then herringbone, then next one is a double main system. So if your land is labeled land, and if there is only one main, you have the main drainage system, you have one main drainage system, and you have the laterals. These are called as the laterals. So laterals are present only one side of the main drainage channel. So you have only one main drainage system, and there are different laterals, and these laterals are provided only one side of the main. This is called as the grid iron. So grid iron drainage system is practiced in which type of land? Somewhat labeled land. Okay. Coming to herringbone system. Herringbone is a type of fish. You have seen the fish. So if it is a fish bone, you have seen the bone is like this. So herringbone system means there is only one main drainage system or drainage channel, and both sides of the main channel there are the laterals. Okay, so laterals are provided from both sides of the main, and as you have only one main means there will be two slope surface will be there, and there will be narrow depression between the two slope surface. So if narrow depression between two slope surface will be there, so you have to install only one main, and so you have only one main drainage system, and from both slopes the laterals will join, okay, from both sides. Then coming to double main system. Double main system means, suppose here narrow depression, but if there is wide depression between the two slope surface, that means you have to install two main drainage channel. This is for this slope surface, and there is for second main drainage channel for this slope surface. So two main drainage system, and they have separate laterals, and the laterals is provided only from one side. This is called as the double main system. Okay. So last one is the mole drainage, and other is vertical drainage. Mole drainage means, you can search in the Google mole plow. You can search the Google mole plow. Mole plow means you have already I want to decrease the, so in these cases whatever the things are there, in these cases I have installed either pipe or tile in the subsurface. But in mole drainage I am not installing the pipe. I am creating a pipe like structure, not the pipe. I am creating a pipe like structure. So there is an instrument like this, an instrument will be there, and it will create a hole like structure in the subsurface region. So automatically the water will drain into the pipe. This hole or this pipe like structure is created, and it can be present, it is stable in case of which soil? Clay soil. But if it is sandy soil, then obviously the structure will be broken down. But if as it is a clay soil, hence the whatever the hole or pipe like hole you have created, it will remain for 3 to 5 years. Okay, by using the which plow? Mole plow. Okay. Then next, coming to vertical drainage. I have told you, suppose this is my field. And I have created a well like structure. Then what will happen? I have told there will be seepage, loss of water will be there from the field. Due to the lateral movement, the water will enter into the well. This is called as well. Vertical well will be there. So due to the lateral movement from the field, the excess water from the subsurface region will enter into the vertical well, and water will be collected here. So automatically the water table in the field is getting decreasing. So this is the basic chapter of the drainage. Okay. So here we have covered both surface as well as the subsurface drainage. Thank you. And it is more important in terms of different entrance examinations also. Okay. So basically this is important: gridiron, herringbone and double main system, and in which cases these approach will be we have to follow. Okay. Thank you.